This is section 7.5, which is the sum and difference formulas. So the first things I want you to notice, let's just take a look at this first chart up here. There's a bunch of formulas up here, and I know this can seem intimidating. But first of all, they are really very straightforward. There are a couple of things I want you to notice. First of all, that letter right there is pronounced alpha. That is the Greek letter alpha, and that letter right there is pronounced beta. So they're just like theta, they're just different letters, Greek letters that we would use instead of our normal Arabic numerals that we use. So we're going to look at this as just Greek letters, alpha and beta. So don't let the alpha and beta intimidate you. The second thing I want you to notice is a couple of sign things that are very important. We're going to notice a few things. First of all, in every cosine formula where there's a plus sign or a minus sign, it doesn't matter. Every time you have a cosine problem, the formula that it's equal to is the opposite operation. So see how here it says plus, here it says minus, here it says minus, here it says plus. So notice that cosine is going to give us the opposite operation. Then I want you to notice that sine, in both sign problems, whether it was a plus sign or a minus sign, they give us the same operation. In other words, anytime you see a sine problem, it's going to give us the same operation. And tangent is a little different because tangent gives us one of each. Tangent gives us one of each. On the top, it matches the operation. On the bottom, it is the opposite. On the top, it matches the operation. On the bottom, it's the opposite. So tangent's a little different. It gives us both operations no matter which one we are actually using. So those are a couple things you're going to notice. Now, you're not going to have to memorize these. These are given to you on your cheat sheet, but we are going to have to use them. So we need to become familiar with them. So I'm going to give you a little way to kind of remember what we're looking. It's going to seem a little silly, but stay with me. On the cosine ones, all I could think of when I looked at this was s, and therefore I heard chugga chugga shoo shoo, chugga chugga shoo shoo. And so I started thinking of a railroad track. And every time I saw cosine, cosine, sine, sine, I knew I was looking at chugga chugga shoo shoo. And I know that trains run on opposite tracks all the time. So I said to myself, cosine, cosine, opposite track, sine, sine. Chugga, chugga, opposite, shoo, shoo. So when we use these letters, you're going to hear me saying chugga, chugga, shoo, shoo, and that's what I'm talking about. On the sine ones, I thought about it looking like this, that the cosines were in the middle, and I thought about what else could I make that has C in the middle. And I know this is silly, but I thought of a simple cheese sandwich. And so on a sandwich, you have the sandwich bread on the outside. It starts with S, so sandwich. And you have the cheese in the middle. And I called it a simple cheese sandwich because the sign simply stays the same. So chugga chugga shoo shoo on the alternate track, and a simple cheese sandwich with the cheese in the middle, and it's simple, so the sign matches. I don't really have one for tangent, but you can come up with your own. So the next thing we're going to do is we're going to actually look at how this can be applied. What can we do with this so that we can apply these formulas? Well, let's get to a problem, no calculator today, where we have the cosine of 7 pi over 12. Now, 7 pi over 12 is not on our unit circle. And so I need to find two angles with either a sum or difference of 7/12. Of 7 pi over 12. So I need to find two angles with 7 pi over 12 as a sum or difference. Now you're looking at your unit circle and you're going, well, I don't have any 12ths on my unit circle. And you're right, you don't. But you do have pi over 6, you do have pi over 3, pi over 4, pi over, and let me swap these. Pi over 4, pi over 3, you have pi over 2. If I take all of those and I convert them, in other words, I rename them with 12th as the denominator, because I wanted 7/12. Isn't this 2 pi over 12? This is 3 pi over 12, and this is 4 pi over 12. Well, now I've got two angles that add up to 7 pi over 12. So I'm going to rewrite cosine of 7 pi over 12 is equal to the cosine of pi over 4, which is 3 pi over 12, plus pi over 3. Now I can look at this, and I want you to recognize this is cosine of alpha angle and cosine of beta angle. So I have an alpha and I have a beta. And those add up to 7/12. Now I can use my chugga chugga shoo shoo formula. I can write cosine of alpha, which is pi over 4, times the cosine of beta, which is pi over 3. So chugga chugga. On the opposite track, so instead of plus I wrote minus, sine of alpha, there's alpha, times the sine of beta, and there's beta. So chugga chugga shoo shoo on the opposite track. Now I have things on my unit circle. I know that the cosine of pi over 4 is root 2 over 2. And I know that the cosine of pi over 3 is 1/2. I know that the sine of pi over 4 is root 2 over 2, and I know the sine of pi over 3 is root 3 over 2. I'm now going to multiply these together, so that's going to be root 2 over 4 minus root 6 over 4. And we have now a common denominator, so I'm going to make that one fraction root 2 minus root 6 over 4. Now, both of these answers are acceptable. But your calculator, your computer program, if you're doing your homework on computer, is going to want to have this written. Also, if you're taking a multiple choice test, this answer won't be here, but this one will. So make sure you simplify as much as you can. So let's do the second problem. This one's in degrees, and I want you to think of, we're going to find, let me draw a line here so that you can see that that really is a prior problem. I want to find two angles with 15 degrees as a sum or difference. Now, there were a lot of places on the unit circle that had a sum or difference of 15 degrees, but I chose the easiest two. I thought about the fact that the cosine of 15 degrees is equal to the cosine of 45 degrees minus 30 degrees, because 45 minus 30 is 15. Well, here we go again. I have another cosine of alpha. Remember, we're looking at two angles, so this one's alpha, this one's beta. So I can rewrite this as a chugga chugga shoo shoo problem. So I've got cosine of 45 times the cosine of 30 on the opposite track, so it becomes a plus sign. Sine of 45 times the sine of 30. Now the cosine of 45 is root 2 over 2. The cosine of 30 degrees is root 3 over 2. The sine of 45 is root 2 over 2, and the sine of 30 is 1/2. And that equals, we're going to multiply these two together, root 6 over 4 plus root 2 over 4. And I'm going to simplify that to root 6 plus root 2 all over 4. The last one we're going to do here is I need two angles that add up to 19 over 12. Now that means we're going to have to get a little bigger. We're going to have to go into quadrant 2. And I found, after doing my common denominators, that 2 pi over 3 and 3 pi over 4 were 8 pi over 12 and 9 pi over 12, and that adds up to 17 pi over 12. So I'm going to rewrite the problem as sine of 2 pi over 3 plus 3 pi over 4, and I notice that that's a simple cheese sandwich problem. So I rewrite that as sine of 2 pi over 3 times the cosine of 3 pi over 4 plus the cosine of 2 pi over 3 times the sine of 3 pi over 4. That's going to give me root 3 over 2 times negative root 2 over 2